For months, the Luftwaffe had a working script for survival: come in fast from the beam, ride a curving approach through the bomber box, flash past the tracers, and be gone before the Americans could solve the angle. Through the winter of 1943 and into early 1944, it often worked. Head-on slashes shattered noses, stern attacks raked tails, and the big fortresses bled altitude in black smoking steppes. Then suddenly, the angles that used to be safe turned murderous. FW-190s and BF-109s that once sliced cleanly across a formation began to jolt mid-pass shed panels and cartwheel through their own contrails. On the surface, nothing had changed: the same guns, the same bombers, the same sky. What changed was where the Americans were aiming. A waist gunner peering through fogged goggles now held his sight not on a German canopy, but behind it, riding a smooth traverse that felt all wrong to every bird-hunting instinct he owned. A P-51 pilot in lag pursuit let the glowing pipper float aft of a weaving target and squeezed anyway. On destroyers screening the invasion lanes, Navy gunners kept a reticle picture that looked late while a low attacker raced past the bow and the shells arrived ahead. It looked like error and landed like inevitability. The Axis read it at first as luck or as a fluke of concentration in one crew. But the pattern kept repeating across squadrons and seas: hold behind, hit ahead. The physics were invisible. The results were not. What had been a solvable riddle of timing became a new kind of trap sprung by training, and a little glass disc that moved the solution where it had to be, not where a pilot's gut said it should be. Success turned to attrition, and attrition to fear without a new caliber fired, or a new airplane fielded only a new way of putting bullets into moving air. Before the turn, the Axis confidence rested on real experience. German fighter doctrine refined over years of combat taught that American defensive fire was wasteful and undisciplined. Most gunners snatched at the nose led too little in a crossing pass and froze under speed. The answer was speed and geometry approach, from quarter or head-on, where the bomber's arcs overlapped poorly, compress the distance fast enough to outrun guesswork, and trust the reflex of an expert with a fixed ring sight. In that world, deflection was an art a veteran could master, and a novice would botch. The Luftwaffe's 1943 tally sheets. Schweinfurt, Regensburg, the deep raids that ripped formations to shreds seemed to prove it. In the Pacific, low skippers and kamikaze trainees learned a similar lesson against shipboard mounts. Hug the wavetops across the target's beam and believe the splashes would walk behind your tail. The technical frame matched the culture. German engineering fetishized precision solved by the pilot's brain: calculate the lead pick, the instant fire, a short, lethal burst. The American reflector sights they derided were in early forms still simple glass and paint. The better marksmen among Axis pilots considered them crutches for the unskilled. Bomber boxes looked ponderous. Navy gun crews looked green and over-equipped. American gunnery films, when intercepted, looked like propaganda for men who could not shoot. Even when intelligence whispers mentioned new sights in Allied fighters and strange circular reticles on ship decks, the assumption held machinery could not replace the feel in a wrist, the judgment in an eye, the split-second nerve that won dogfights and attack runs. Confidence hardened into habit. Habits hardened into tactics. And tactics, by mid-1944, were about to collide with a quiet American inversion of the aiming problem, one that turned deflection from art into arithmetic and arithmetic into a repeatable picture any well-trained crew could trust, even when every instinct screamed it was wrong. From the Axis vantage point in 1943. Early 1944. American gunnery looked like noise masquerading as firepower. German staff studies and squadron briefings leaned on a simple reading. The Yankees hauled a small armory into the sky, 850s, in the nose of a P-47 turrets, studding a B-17 Oerlikons and Bofors, bristling off destroyers and then sprayed. Volume, not virtuosity. To a culture that prized the pilot's eye and wrist, that was an invitation to ridicule. The fixed ring and bead and early reflector sights the Americans fielded seemed crude, the kind of training wheels you give a novice. Real deflection, the story went, lived in the fingertips of a veteran who could sense angle-off closure and range in a single burst that started and ended within a heartbeat. They also thought they saw systemic weaknesses they could exploit. Bomber gunners fighting from vibrating, unpressurized stations tended to snatch at the trigger as a fighter flashed across the window. That jerk, combined with turret inertia and slack in traverse gears, threw patterns wide. Tracers, which Americans used liberally for feedback, betrayed the same lie over and over in a crossing pass. The glowing streaks looked late, so nervous, gunners yanked the stream forward with sharp, discontinuous swings, destroying lead rather than establishing it. The Luftwaffe briefed attack geometries that fed this illusion beam and quartering passes that maximized apparent target speed across the glass, forcing over-control and an underlead that left holes in the air behind a 190's tail. Convergence and harmonization were another Axis sneer line. U.S. fighters bristling with wing guns relied on a preset distance at which bullet streams crossed. In the hands of a pilot who misjudged range harmonization punished him twice, his pattern diverged, and his perceived good picture lied. German centerline cannon and machine guns put everything on the bore sight. You pointed the airplane, and the bullets followed. In barroom logic that felt like battlefield truth, centerline meant deadliness. Wing spray meant waste. Over water, Japanese aviators extended the mockery to shipboard mounts. American topside gunnery, they believed, chased the nose of a low attacker with a panicked barrel. A torpedo run hugging the troughs could skitter under a director's solution lag and pop up only when it was too late. A diving bomber could knife through the parallax and leave the burst walking behind it. The American reliance on directors and stable elements. The whole orchestration of pointers, trainers, talkers felt like a bureaucracy between man and gun. In a war of seconds, bureaucracy bled seconds. Training pipelines were yet another perceived crack. The Axis consoled itself with the notion that America's mass pilot and gunner production produced competent operators, not hunters. Put a green gunner in a vibrating icy waste window at 25,000 feet and tell him to solve a 300 map-per-hour crossing target at 300 yards with a simple ring, he will underlead flinch and empty a belt for nothing. Put a newly winged fighter jock with a plain reflector sight into a rolling scissors, and he will aim at what he sees, the canopy, rather than where the canopy is going. He will plant his sight on the nose and etch harmless dots up the sky. Doctrine would not save him. Experience would, and experience, the Axis believed, was what they had in spades. Underneath the bravado lay a technical bet that feel could outrun math. American optics that did not compute lead in real time were forever behind the problem. American crews saturated with guns and tracers would keep teaching themselves the wrong lesson. If the United States wanted to hit fast-angled targets, it would have to produce aces by the thousand impossible. So the Luftwaffe and IJN doubled down on the tactics that made American aim look foolish, curved high-rate passes through bomber arcs. Beam-skimming torpedo runs. Last-instant jinks that forced the opponent to chase a picture already gone stale. The mockery felt earned, until the picture in American glass began to move on its own, and the wrong sight picture held stubbornly behind turned right. Beneath the thunder of industry and the confidence of numbers, the Allies faced a single stubborn truth: most misses were geometric, not moral. Courage did not bend bullet paths. Training could only go so far against human timing limits. In the 8th Air Force, every deep push to Schweinfurt, Regensburg, or Berlin wrote that truth in aluminum and smoke. Waist and tail gunners lived inside a calculus problem with too many moving terms: target angle, off closure rate, own ship motion. Turret slew time of flight gravity, while oxygen masks iced airframes shook and the horizon skidded in the glass. You could preach lead more all day. Under stress, the brain aimed where the eye saw the airplane. And where you see the airplane in a hard crossing pass is not where it will be when the bullets arrive. Fighter pilots faced the same curse with a different view. In lag pursuit, the correct solution demanded a continuous smooth track and an aim that seemed to violate hunting instincts. Pull the nose across too soon, and you overshoot. Plant the sight on the canopy, and you trace a luminous underline beneath the enemy's path. Even experts bled accuracy when the fight tumbled into high-rate turns. The problem compounded with harmonization errors and misjudged range. At 300 yards, a tenth of a second of timing error, or a degree of lead error, was the difference between corkscrewing rivets and a dead pass. At sea, the Navy lived a parallel nightmare. A torpedo bomber ripping the ship's beam at wave-top height offered perhaps 5 seconds of useful tracking to a mount crew. The ship rolled, The mount traversed against inertia and wind. The talker's cadence fought the gun captain's instinct. Gunners chased the airplane and landed their bursts a ship length, late over and over, against coordinated raids and later kamikaze dives. The cost of underlead was not a statistic. It was steel and lives. You cannot wish a mount faster or a crew calmer when closing speed is measured in football fields per second. The cumulative effect was grim arithmetic. Escort fighters burned ammo for marginal hits. Bomb groups took losses that bent mission planners into contortions. Destroyers and carriers spent thousands of rounds to claw down too few attackers. The Americans were not out of guns or courage or factories. They were out of time inside each engagement to let a human compute deflection perfectly. The war had exposed a bottleneck. No heroism could widen the loop from eye to brain to hand was too slow and too error-prone for 300 mph geometry. So the requirement crystallized quietly, brutally, into a search for a secret weapon Y that wasn't a bigger gun or a faster airplane, but a way to delete the math from the man. Y would have to do three things simultaneously. First, move the aiming point to where physics says the bullet stream must go, not where intuition begs to put it. That meant a reticle that floats with your turn rate and the target's apparent size an analog computer in glass. Second, stabilize the habit of doctrine that taught crews to trust an incorrect picture aim behind, to hit ahead, and to track smoothly instead of chopping at the target. Training films, simple checklists, and standardized harmonization would make average crews good enough every time. Third, scale. Without drama, a device rugged enough for flight lines and salt spray, simple enough for a conscript to maintain, cheap enough to deliver by the crate, and consistent enough that a gunner reassigned tomorrow would see the same reticle and the same rules. Until Y existed in that complete shape device plus doctrine plus distribution, the Allies were paying a tax on every sortie and every watch wasted rounds, missed windows, lives lost to timing errors measured in tenths. The United States could not afford to graduate a nation of virtuosos. It had to industrialize accuracy. The bet was stark: if you can turn deflection from art into procedure and procedure into a picture, any trained crew can hold. Under pressure, the casualty curve bends. That was the urgent need written between the lines of mission reports and after-action laments. The factories would answer. The labs would spin. The manuals would change. And when Y finally rode to war in a small metal box with a gyro at its heart, the angles of the sky would tilt without changing a single caliber or painting a single new star on a fuselage. They did not begin with a miracle weapon. They began with films of failure. On a wooden table at R.A. Farnborough, reels from gunnery trials unspooled into the dim tracers, forever carving luminous commas behind a crossing target, pilots swearing they had the picture, and still coming home with empty belts and no kills. On a chalkboard, someone wrote a small equation that felt like treason to romance: lead equals turn rate times time of flight. If the sight could feel how fast the shooter was rotating, and the gunner could give it just a rough sense of range, the glass could move the aiming point to where physics said the enemy would be. That was the heresy. Deflection was not a gift, it was arithmetic. The first contraption looked nothing like salvation. A rate-gyro, a spinning mass in a small, stubborn cage, hummed on a bench. Wires ran to a breadboard analog computer that pushed a reticle across a pane of glass mounted on sliders. A bakelite knob marked wingspan made the whole picture widen and narrow like a clockmaker's trick. Test pilots from Boscombe down took the lash up into the air in modified hurricanes and attacked toed sleeves under strict orders: keep the target smoothly bracketed, don't snatch, set the wingspan so the caliper just kisses the tips. The gun camera film did not lie. Novices, once they trusted the moving dot, started punching more holes in fabric than veterans with fixed sights. A bland label, gyro gun sight, hid a revolution. Farnborough passed drawings to Ferranti and Manchester. Production call signs GGS Mech 2, then Mech 2E followed. Engineers learned the temperament of the spinning heart: damp it too little, and the reticle shivered. Damp it too much, and the dot lagged the pilot's hand. They added caging levers so crews could lock the gyro during taxi, and violent maneuvers standardized power feeds so brightness held steady when a turret slewed, drafted boresight and harmonization routines, so what the dot promised, the barrels could keep. Nothing here was magic. Everything here was discipline. Across the Atlantic, Wright Field's boardrooms filled with the same films and the same impatience. The 8th Air Force could not afford to teach every man to feel a 300-mile-per-hour crossing shot. The Navy could not allow deck-level attackers to keep skating under shipboard fire. In 1943, naval ordnance married a rate-gyro to rugged optics and a compact resolver, and christened it MAU-14, a lead computing sight that slid onto Oerlikon 20mm and Bofors 40mm mounts, like it had been waiting for the war to need it. The Army Air Forces, watching RAF squadrons report startling improvements, and invited into the British tent, licensed the concept, and tasked AC Sparkplug to build the fighter version at scale. The designation K-14 didn't sing, but the factory output did crates with identical boxes, identical manuals, identical spares. The secret lived less in classification stamps than in habit. Pilots and gunners had to be taught that the correct sight picture would look wrong. Training films replaced hunting lore. Do not chase the nose. Set the wingspan. Keep a steady track. Fly the pipper. Armorers learned to treat the sight like a living instrument, spin-up checks, reticle centering quick swaps of plug-in gyro heads in cold revetments. On destroyers' mount, captains drilled crews to hold the reticle picture and ignore the urge to yank the stream forward. In fighter pens, instructors walked students through the first shock. The dot floats aft of a weaving FW-190. You squeeze against everything your body believes, and the gun camera plays back an explosion of coolant a half-second later. There were missteps. Early units complained of jitter over certain engine harmonics, of drift after long, rough flights, of misset wingspan cams that turned a Mustang against itself. Each failure turned into a checklist line and a field fix. The manuals fattened in the right ways, short paragraphs, little drawings, numbers a corporal could trust. The doctrine hardened around a simple covenant: if you give the sight a smooth track and a plausible range, it will give you the future in glass. By late 1944, the idea that had looked impossible, removing deflection from the brain and putting it into a box, had moved from blackout labs to briefing rooms. The RAF carried Ferranti's GGS across the channel. The USN bolted Mag-14s around the Pacific Fleet until every beam seemed to glow with moving reticles. The USAAF strapped K-14s into Mustangs that went deep over Germany. The laboratories had done their part. The rest was just repetition of crates on docks, of checklists in cold mornings, of a new reflex that said, hold what looks behind, and the stream will arrive ahead. Begin with the heart. The rate-gyro does not see the target. It feels you. Spin a small rotor, suspend it so it resists changes in direction, and it will generate a signal proportional to how fast the gun or aircraft is rotating. In a tracking attack, that rate is the skeleton key. A higher turn rate means a bigger angular lead is needed for the same range. A lower rate means less. Feed that signal into a simple analog computer, a handful of resistors, capacitors, cams, and you can command the reticle to move opposite your turn by the exact angle that places bullets where the target will be when they get there. The pilot does not add lead. The sight is lead. Range. The second ingredient is guessed cleverly rather than measured exquisitely. No radar pulse, no mystical depth cue, just a wingspan dial tied to a cam. Turn the knob until the target's wingtips kiss the reticle's caliper marks, and basic geometry gives you range because apparent width equals real width divided by distance. That estimate is good enough because the system is updating constantly as you track. A 10% error in range still yields lethal solutions at the short, violent distances where World War II gunfights were won. Now the alchemy as you are now solutions. Fixed sights freeze the world. You pick one instant to fire, and if you misjudge, the burst goes to history. A gyro sight's moving reticle encodes a living answer. If you keep doing what you are doing right now, this is where to send the stream. Change your turn rate and the dot slides instantly. The computation is continuous, not episodic. The doctrine that rides atop that math sounds deceptively simple. Keep the pipper on the airplane and keep the track smooth. The illusion that once fooled every hunter, I must drag the sight in front of the nose, is replaced by a habit that looks wrong and hits right. Everything ugly in the real world was accounted for. Vibration that made early reticles quiver met damping in oil or spring. Taxi jolts that could wound a small spinning mass met caging levers to lock the gyro until airborne. Electrical quirks met standardized 28-volt feeds and brightness controls that did not flicker when a turret swung. Bore sight and harmonization procedures welded the math and glass to the metal of barrels at the distances that mattered. On ships, pedestal mounts were tuned so the sight's sense of turn wasn't swamped by transverse inertia. In fighters, the optics were braced against engine harmonics. This was not a toy you handed to an ace. It was an instrument you entrusted to an armorer who had slept 4 hours and still had grease under his nails. So why couldn't the Axis erase the advantage with a single counter or a clever copy? Because Y was a triangle, not a talisman device, discipline distribution. Germany's EZ-42 gyro sight proved the idea wasn't uniquely allied, but production came late. Airfields burned, fuel dwindled, and pilot pipelines collapsed. A box without the spares, jigs, and trainers to keep it identical across squadrons is just a box. The Allies treated sights like ammunition, interchangeable, documented, shipped by the thousand, taught the same way in Norfolk and Norfolk in England, because there was nothing to jam. A gyro sight emits no energy. Chaff and noise are meaningless to it. The only countermeasure is to break the shooter's ability to maintain a steady track. Violent, randomized jinking range changes outside the envelope. But by late 1944, the Allies owned enough sky that such evasions often traded survival now for death seconds later. Escort doctrine punished the maneuver that spoiled one gun run by setting up 2 more, because intelligence couldn't see the picture that mattered. From the outside, a K-14 looks like any other gun sight. Interrogations could capture the phrase moving reticle, even seize a specimen, but without calibration, rigs, without power standards, without the unglamorous depot work that keeps the dot faithful, the device is a sculpture. Even if you made it sing, you still had to unteach a pilot's instincts and replace them with doctrine that says trust the aft pipper. That rewiring takes classrooms, films, and time commodities the Axis had in deficit, because it changed the average, not the ace. Aces were always going to solve some pieces of geometry by feel. The gyro sight's cruelty was statistical. It turned the solid pilot and the competent gunner into reliable hitters in the very situations that used to punish them. German and Japanese tactics that relied on the median American to underlead a beam pass through a bomber box, a deck-level beam run on a destroyer, began bleeding at the median. You do not need every shooter to become a killer. You need most shooters to stop being wrong in the same way. And finally, because doctrine protected the illusion. The human animal wants to aim at what it sees. The Allied syllabus replaced that reflex with a picture you learned to love: pipper seemingly aft, hits arriving ahead. Position firing. Fly the pipper. Do not chase the nose. When this catechism is the same from Spitfire pens in Kent, to Mustang revetments in East Anglia, to Bofors tubs off Okinawa, you have done more than field a gadget, you have standardized a truth. The Axis could admire or deride the glass as they pleased. By the time they felt what it did to angles they once called safe, the truth had already been installed, caged, uncaged, harmonized, and taught again tomorrow and the day after that. Dawn breaks hard and high over the Philippine Sea, June 19th, 1944. Heat stacked in layers, the carrier wakes, breathing aviation fuel and coffee. On the starboard side of a fast carrier task group, a 40mm Bofors tub is already alive. Loaders pass, clips up in a ritual of steel, the mount captain calls. Stand by the pointer and trainer settle their cheeks to rubber pads. Bolted to the cradle, a compact box of glass and cogs hums to life. The gunner's face goes soft with concentration as the reticle blooms in the eyepiece and then almost imperceptibly begins to move when he slews the mount. The new sight has no poetry in its name, Mach 14, but it keeps a promise: if you hold the picture, the future will keep the appointment. The raid comes like a rumor, becoming a scream. Green dots on the fighter director's plot. Then black specks, then visible wings hugging the horizon's blue seam. Bogey's low starboard beam. The mount swings and the Mach 14's reticle slides of its own mind, a luminous coin drifting aft of a Kate's canopy as the gunner speaks to himself. Don't chase the nose, hold the dot, track smooth. Old muscle memory yanks at his wrists. The sight's moving, math yanks harder at the mind. He keeps the picture. First burst breaks water short and wide correction stutters in the reticle rather than in his hands. The Kate stays welded to the caliper of light. He squeezes as the commander calls range. The stream leaves the barrels from a point that looks late rides the ship's own motion forward and finds aluminum that will be air for only another 5 seconds. The plane shivers, tries to lift unthreads into pieces. The mount captain does not cheer. Next, he barks. The math is busy. All around the formation, the same small miracle repeats in tubs and director's pointers who once dragged streams under bellies now hold a picture that refuses to lie. Some attackers jink with the old contempt counting on habit. The habit is gone. Those who try to pop up for the torpedo drop meet shells that appear to be waiting. The word luck dies in throats because luck doesn't happen this many times in one morning. The battle will be named the Great Marianas Turkey Shoot, but the birds are mechanical equations, rate-gyro outputs, cam curves, tied to guessed range reticles displaced by lead angles. The human hand misjudges when the world is moving 300 miles an hour. Flip the calendar and slide a finger along the map to northern Germany, December 24, 1944. The air as thin and hard as hammered glass. 8th Air Force has sent its box formations deep toward the Ruhr on the coldest mission of the month. The escorts, long-legged and tired-looking, flicker above and outside the stream. In the lap of a P-51 pilot, familiar totems ride along a checklist stained with engine oil, a small notebook of wingspans, 109 10 meters, 190 10.5, and the new sight that the crew chief wired in last week. The designation is K-14, but the pilot calls it the pipper that won't behave. He turns the wingspan dial until the FW-190, he knows he will see sometime today, will fill the caliper, just so, at a killing distance. When the first pair of 190s rake down the sun line, he does not do what his hunting uncle taught him when he was 12. He does not drag the sight in front of the nose. He slides the selector to gyro, keeps the track butter smooth, and lets the dot float where physics wants it aft of the canopy in a picture that makes his stomach itch. The reticle wanders with every change in his own turn rate, a live solution in glass. He waits. The airplane moves. The dot and the target cross paths in a way that used to require faith and now requires obedience. He squeezes in a long, calm press. The burst looks like an apology until the 190's coolant rips free like fog. The German rolls and tries to bail through a split S he will not finish. Down in the bomber box, a waist gunner with numb fingers tracks a slant ingressing fighter and repeats a new catechism. Position firing. Hold what looks late. The turret's inertia, once the enemy of smooth traverse, is now an ally. The moving reticle lives on top of that smoothness. He rides the sight through the pass, feeling the ship's motion carry the stream forward. The film that comes back later will show what he cannot see in the moment bullets arriving, where a second ago there was only empty sky because a second ago is where he used to shoot and miss. The lesson has been rewritten by a small machine. Both theaters, Salt and Contrail, report the same sensation when at day's end. The fighting felt easier in the places where it used to feel impossible. On the carriers, the mount captains notice ammo consumption per downed attacker bending in the right direction. On the frozen fields, pilots write sheepishly that their first wrong-looking shots were the best of their lives. Armorers discover a new rhythm, spin up the gyro on the ground, check the reticle centering, swap out a gyro head with a screwdriver, and a shrug when one drifts. The genius has moved from individual wrists into a standardized habit, itinerant, repeatable, shippable. A week later, the war throws a harder exam, low-light weather, moving in a mixed bag of targets' distractions that used to pull reticles and attention off the solution. The sights do not care. The picture still holds. The reticle still drifts aft with your turn, still leads invisibly with time of flight, still encourages a smoothness that defeats panic. The technology requires neither a brave man nor a brilliant one. It requires an obedient one. In a conflict that has been teaching cruelty to averages since 1939, the side that changes the average wins. By Christmas, the average Allied gun run looks like a physics demonstration. By New Year's, it is won. The after-action conferences do not call it magic. They call it standardization, same box, same knobs, same syllabus, from Norfolk to Norfolk in England. The reticle is a dialect of the same language. Hold the picture, trust the math. And when the next crate opens at the next airfield, or tender, another crew will learn the same lesson. You can aim behind and hit ahead, because your own motion is a conveyor. The enemy cannot see until his airplane begins to shake. At first, they call it luck. A zero pilot who has skimmed destroyer wakes since the Solomons watches a wingman pitch into spray a half-second sooner than the old mental math says he should have. The tracers looked late, he swears it, and yet the bursts arrive in front of the nose, as if the ocean itself shoved them forward. Bad timing, he tells himself, or a nervous gunner who threw a good burst by accident. The next day, 2 more go down and the word accident begins to taste like ash. A Kugelfischer-trained FW-190 pilot will later write that the air above the Münsterland felt rigged, that winter angles that had been safe since 1941 suddenly bit back. He had built a career on the bomber box beam pass come fast from the quarter present, a hard-crossing picture, trust the Americans to underlead and overswing. On Christmas Eve 1944, he flies the geometry perfectly and feels in the instant between lift and fall the sickening stutter of rounds finding the engine's bones. He brakes and looks instinctively for the American fighter he thinks must have overshot in front to get that angle. There is no overshoot. There is only a Mustang and disciplined lag, a tiny moving dot in its windscreen floating behind his canopy, a heresy against every hunting lesson he has ever loved. He does not understand it yet, but he already fears it. Rumor mutates into explanation. Squadron rooms invent words, magnet sights, late pippers calculated lead. An intelligence officer sketches something like a gyroscope on a chalkboard and waves a hand at the mathematics of angular rate. If they are tracking you well, he says, the sight moves the aim for them. The room laughs in the way men laugh at a funeral, because if that sentence is true, then instinct is suddenly a liability. Mockery buys nothing, not even courage. On carriers and convoy escorts, Japanese crews try to recover a margin of safety by changing the dance. Instructors tell them to stop trusting the steady beam run, to throw in random jinks, to break the tracking picture the American sight needs. For a day it works, then the reality of physics comes back with interest. The jink saves one man and kills the 2 who must straighten to deliver their torpedoes. A doctrine that once leveraged the enemy's average underlid now bleeds to an enemy who no longer underleads by default. The sea had grown teeth, a survivor writes years later, and they were waiting in front of our noses. In the West, the Luftwaffe tries the same medicine, violent out-of-phase rolls to ruin the track, sudden dives to break range, a switch to head-on passes where no amount of lead can save the defender. The head-ons hurt both sides and solve nothing. The dives buy seconds and lose position. The rolls punish only the pilot, who has already given away energy. The Allied escort doctrine is indifferent and patient. One blown pass feeds 2 more. In the margins of these fights, the new physics keeps writing its quiet verdict. The man who holds the picture wins. What does panic look like in a cockpit, convinced that the world has betrayed it? It looks like a pilot stabbing the throttle to force an overshoot, because reflex says the enemy cannot hit unless he drags his sight in front, and then discovering that the enemy no longer has to drag anything. It looks like a gunner on a Betty bomber holding a perfect bead on a destroyer bridge and watching the ship's own spray swallow his tracers from ahead, as if the destroyer's wake has learned to ambush bullets. It looks like a Staffelkapitän throwing his best flight at a box of B-17s and calling break on the squadron channel a beat earlier than he means to, because somewhere in him a voice is counting the hits before they happen. The interrogations after capture will read like variations on a single grief. Your fire is better now. You must have trained a new kind of shooter. Your pilots aim behind and still hit in front. The engineers will scribble notes about moving reticles and wingspan knobs and return to burned factories where there are no spares and no time to teach a new religion. An EZ-42 will be mounted on a surviving 109. A mechanic will try to power it and find the wrong voltage. A pilot will lift and swear the dot moved, but not where it should. His gun camera will come back empty, and the sight will be blamed for the sin of promising an equation to a man who was never shown the syllabus. By spring, realization hardens into a kind of fatalism. The angles that once protected you now serve them. The beam passed through a bomber box, the one you perfected in 1943 becomes a coin toss with a heavier coin. The low run on a screening destroyer is Russian roulette with a shorter cylinder. The sense of being hunted by math starts to replace the old contempt for spray and pray gunnery. In pilots' bars, there are fewer jokes about American tracers and more quiet drinking when someone mentions a pipper that drifts the wrong way and still draws blood. A few survivors learn a new harsh wisdom. If you are seen and tracked, you are already negotiating with a calculation you cannot bargain down. Your only hope is to deny the calculation the inputs it needs: no steady track, no consistent range at the cost of giving away your own attack. That is not a tactic. It is an admission. War favors the side that can systematize what used to belong to virtuosos. The Allies have put lead on a syllabus, printed time of flight on a dial, and taught an average man to do the right thing even when his bones think it is wrong. When the shooting stops, some of those men will try to describe the feeling with words like overwhelming and inevitable. A Japanese officer will write that American guns waited in front of us as if the ocean itself had turned conspirator. A German technical officer will mutter that the Americans are dangerous because they make the right answer easy. That is the real confession hiding in the panic once the sky belongs to a picture in glass that tells the truth faster than your instincts can lie. You are not being beaten by luck or by courage. You are being beaten by a small, spinning mass, a moving dot, and an industrial nation's insistence that every man on every day sees the same solution sought when the enemy flashes across his sight. Strategy rarely pivots on a gadget. It pivots on what a gadget standardizes. The gyro lead computing site, paired with the doctrine that told men to trust a picture that looked wrong, did not make heroes invincible. It made ordinary crews predictably lethal in the very envelopes that had favored the Axis since 1941. That single change propagated upward like pressure through a hull. Escort math shifted first. When Mustang groups could convert more tracking windows into kills, deep penetration raids no longer bled combat power at the edges of the bomber stream. Fighter cover stayed thicker, longer, further, and the 8th Air Force's planning horizon widened from "can we get there" to "what else can we hit?" On the way home, the improved per-pass lethality also changed air superiority tempo. Fewer minutes spent re-attacking a single foe meant more intercepts per sortie, which in turn meant more German pilots forced to fight defensive, fuel-hungry engagements they could not afford. At sea, the effect was even starker. Shipboard gunnery had always been a race between traverse and closure. The MCO-14 stretched the useful part of that race by converting steady tracking into reliable lead at deck level. Carriers and their screens did not become impenetrable, but they became predictable in the right direction. Ammo per downed attacker trended down across task groups, and commanders could assume with far less hedging that a set of mounts would intersect low-fast threats without the old walked-behind tax. That predictability underwrote operational audacity. Fast carriers pushed deeper under thinner fighter caps. Amphibious forces accepted beaches that previously looked too exposed to low-level runs. Radar picks held stations longer because the last line of guns actually closed the geometry. Training and logistics absorbed the shock with ease because the shock was designed to be absorbed. The same site, same knobs, same syllabus from Great Lakes to Great Britain meant a replacement crew could step into a tub or cockpit and inherit a working language on day one. Instead of minting virtuosos, the United States minted consistency. Consistency is the true coin of industrial war. It bends attrition in increments that compound. A few more attackers killed on day 1 become a few more ships intact on day 10. A few more escorts surviving to the bomb line become fewer flak sites operating on day 30. Axis counter-tactics. Jink harder dive earlier force head-ons carried hidden strategic costs. Hard jinks bled energy they could not spare. Early dives surrendered altitude that turned into Allied position. Head-ons mortgaged pilot pools already in deficit. In effect, the gyro site taxed the enemy twice, once in the moment of being hit by a mathematically honest stream, and again in the operational distortions they adopted to avoid that stream. By late 1944, the Allies were no longer asking their average shooter to do the impossible. They were asking him to obey. That obedience hold the wrong picture. Keep the track smooth, set the wingspan scaled across thousands of engagements. The aggregate result did not look like fireworks on a single day. It looked like campaigns finishing sooner. Fewer bombers lost per mile, fewer ships holed per raid, fewer sorties consumed re-killing the same foe. The war machine did not speed up because men grew braver. It sped up because the sky stopped lying to them. The first confessions were small and bitter, muttered in debrief rooms that smelled of fuel and defeat. A German Staffelkapitän nursing a bandaged hand told an interrogator through clenched teeth, "Your sight moves. If he holds it steady, I cannot cross him safely." A Japanese torpedo leader captured after a raid that never reached the drop put it more simply. "Your guns wait for us." Later, when memoirs hardened and engineers picked through wreckage with calipers instead of hatred, the sentences grew colder. A Luftwaffe technical officer summarized the Allied advantage with an engineer's cruelty. They standardized the correct solution. Not a larger cannon, not a secret ray. A standardized solution delivered in glass, explained in a leaflet serviced by a corporal with a torque wrench. German armaments officials who had spent the war worshipping virtuosity because industry could not supply uniformity recognized the trap too late. One post-war report on air combat aids conceded, "A device that improves the median pilot is of higher worth than a device that flatters the expert." The gyro sight did not flatter anyone. It erased the single most common human error in a 300 mph crossing fight and made that erasure available to everybody who followed a 3-step ritual: set the span track smoothly, trust the pipper. Japanese officers writing about the last furious year at sea circled the same admission from the deck's edge. "We believed their fire chased the nose," one gunnery officer recalled. "Then we saw it arrive in front. After that, our tactics were ideas, not safety." The italics were his. He had watched doctrine detach from physics and drift into superstition. Superstition does not shoot down airplanes. Even among Axis engineers who attempted parity, the verdict held. A test pilot who flew with Germany's late-war EZ-42 gyro sight, rare, badly supported, intermittently functional, sounded more weary than angry. Ours sometimes worked. Theirs worked everywhere. Everywhere is a strategic word. It contains supply lines, training films, bench jigs, and a petty officer who knows which screw to turn when the reticle jitters at idle. Everywhere is the difference between a clever box and a campaign tool. The most honest line belongs to a man who spent his life believing in the heroic individual. He allowed himself one sentence of heresy after the guns fell silent. They make it easy for an average man to do the right thing. In that sentence is the whole architecture of defeat. For a decade, the regimes of Berlin and Tokyo had fashioned war around the miraculous outlier, the ace who could feel deflection, the skipper who could surf spray. Against an enemy that industrialized accuracy, the miracle became a liability. Angles betrayed old hands, safe windows closed, the sky kept a new promise. So let the last word be simple and earned. The Allies did not win because their men stopped being human. They won because their machines, small ones, spinning ones, humble ones, taught humans to aim where the future will be, not where the past still is. And when the other side finally said it out loud, they were not praising the gadget. They were describing a nation that could turn one true picture into a million obedient hands.